Good evening, everybody. It's been a long time since I've actually sent out a video. We've been working really hard on getting our papers done. We're done, yay! But I do want to send out some information regarding what we've been studying in class so that you can take a look and see and make sure that you understand the concepts that have been presented in class. So far, so good. Been doing well, but I just wanted to send this out just for your information. And so I want to take a look at the different kinds of angles, what they all mean and how they look, so that you can study them as you're preparing for Friday's assessment. So we have our first angle, which is our acute angle. That is a small angle. It's less than a right angle. We have an obtuse angle that's greater than a right angle, and a straight angle, which is also greater than a right angle. But how do they actually look? Well, our right angle actually forms a corner, or it looks just like this. Now it can be turned in different directions, but it still has the same degree of measurement. So it's at a 90-degree angle. When we have an acute angle, it is less than 90 degrees. If it's even at 89 degrees, it is considered an acute angle. So I'll just give you an example of that. If you have an angle that looks like this, it is smaller than the right angle. If it could fit into the right angle, then it is considered an acute angle. An obtuse angle is anything greater than a right angle. Kind of would look like this, whereas you see that you can fit your right angle right in there really nicely, and you still have some space left within this angle. In that particular case, it is an obtuse angle. A straight angle is also greater than a right angle, but what makes this straight angle different is that it is literally what it says. It goes straight across. It is actually a line, okay? Our angles are basically two rays, right here, that are put together in order to make an angle. When you have both of those rays put together and they go straight across, then it is considered a line or a straight angle. Okay, just to give you guys an idea of what we're dealing with here. Now, when we deal with lines, there are different kinds of lines that we'll deal with. You have intersecting lines, you have parallel lines, and perpendicular lines. Intersecting lines, they intersect at some point in time. They may continue to run straight through each other, or they may stop at a particular point. Now, intersecting lines, they can intersect sort of like this. But perpendicular lines are a little bit different. Even though they intersect, perpendicular lines intersect and they make right angles. So they literally, you will see a right angle just like that when you're dealing with perpendicular lines. Parallel lines, however, on the other hand, they go straight in the same direction, but they never meet. So now we have our lines, our rays. We have line segments that can also form angles, and they can also intersect at some point in time. Usually a line segment, it intersects at that point and it doesn't go any further. And then the point is basically the space or the area that you see on that particular line. So we have different signs that we use. When we're dealing with a line, we're just dealing with drawing our line with two arrows on both ends saying that the line continues in both directions. When we have our rays, however, it's a little different because we have a point saying, well, yeah, we continue in one direction, but at one direction we just have a point where we stop. Line segment, it has a point at both ends saying, this is just a portion of the line. And so there's an end and there's a beginning and end point with a line segment. With a point, it's exactly what you hear. It is the point that goes on the line as you are trying to find out where things began and ended. Now, I want to skip from line of symmetry for just a moment, and I want to skip down to quadrilaterals because those are really, really important for us to be able to understand and get through. Quadrilaterals are basically shapes that have four sides. Quad meaning four. When we deal with quadrilaterals, you can have, and I'll draw a sort of like a flow chart for you guys to understand. When we're dealing with quadrilaterals, you have two main points, and that would be our trapezoid. Let me make sure I'm spelling this right. Just want to make sure. Yeah. So we have our trapezoid, which is right here. And then we have our parallelogram. And our trapezoid, it has two pairs of parallel lines, but it does not have, it has one pair of parallel lines, but one set of lines, they'll meet at some point in time. So if I were to take this line and continue in that direction, and this line and continue in that direction, at some point in time they would intersect. But these two lines are continuing to be parallel. So you have one pair of parallel lines in a trapezoid, not two. However, in a parallelogram, that's a little different. Because in a parallelogram, you have two pairs of parallel lines. My drawing isn't that great, but you guys get the picture. Okay? Again, in a parallelogram, you have two pairs of parallel lines. The lines that go here, 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 and here. In other words, these two lines never meet because they continue to go in the same direction, and these two lines never meet because they go in the same direction. Underneath the parallelogram, you have what is called the rhombus and the rectangle, and then eventually the square. Your rectangle, there are rules for your rectangle, and there are rules for your rhombus. The rules for your rectangle say you have 4 right angles, okay? And those 4 right angles, also with those 4 right angles in a rectangle, you will have 2 pairs of parallel lines. So just like a parallelogram, you have 2 pairs of parallel lines, but you also have 4 right angles. With a rhombus, you have 2 pairs of parallel lines, but all the sides are equal. Again, with a rhombus, you have 2 pair of parallel lines and all sides are equal. You don't necessarily have, with a rhombus, you don't necessarily have 4 right angles. However, if you take the rules from the rectangle and the rhombus, then you have the square. Because with the rectangle and the rhombus, you take from there, you take the 2 pairs of parallel lines that are in both. All sides are equal here, and you have 4 right angles. Again, you have 2 pairs of parallel lines, and of course it's quadrilateral. So if we're identifying a square, so if we have a square, then it's going to also fall under the category of a rectangle, a rhombus, a parallelogram, and a quadrilateral, not a trapezoid. Just keeping that in mind. So if you were to follow that, then the flow chart down here allows us to know that our square is the same. If we're identifying a rhombus, it may not necessarily be a square, but it could be a parallelogram and quadrilateral as well. So you have to know the rules for each. Now I would say for that, I would say go back and review lesson 10.4 so that you can get clarity on that with more detail, because they give you in that particular area, they actually literally show you each shape and they show you what each one is representing. Also, go back to your reteach sheet that I gave you and we went over in class. Now, I want to go to our last thing this evening, and that is our line of symmetry. Our line of symmetry basically says this: if I were to take an item, if I were to fold it in half, both sides will look identically alike. There is no variation at all. And so when I'm trying to find my line of symmetry, I'm going to try to find out on a particular shape, I'm trying to find out where will it actually be the same. Where can I draw a line where both sides look the same? And so let's take a look at this, for example. Moving the pencil away, if I were to draw a line directly down the center of this item, I'm drawing a line of symmetry. I show my line of symmetry because both sides on either side will look the same. However, if I were to do a line from side to side, then this part looks different from this side, and therefore I no longer am drawing a line of symmetry when I go from side to side. So please keep that in mind as you are studying this evening. Now, I want you to be familiar with, as you take the assessment, by the way, it's online and it's available this evening, I want you to be able to identify all of these various different parts of geometry that we've gone over thus far. Play this video again if you need to, because you need to have it in your head when you go into the assessment on Friday. Please make sure that you're understanding the difference between your acute and obtuse angle. Obtuse means greater than right, greater than a right angle, and acute means less than a right angle. This is greater than a right angle, but it's the same as saying that we have a line. We have lines, rays, line segment, and points. We have a line of symmetry, and we have the different types of line, which are intersecting, parallel, and perpendicular. We have our quadrilaterals, which could be a parallelogram, a rectangle, a rhombus, a square, and a trapezoid. Now, make sure you're studying, make sure you are prepared, and have a good evening. Enjoy yourself. Bye-bye.